or Amperes law. So here is, we have the magnetic field produced by a wire. The wire will produce magnetic field around itself, as we shown before, right? And we did show that what's the direction of that magnetic field. Now, B is equal to mu 0, I current divided by 2 pi r. R is a distance. At a distance around the wire, there will be a loops, right? Further you go, you have a weaker magnetic field. Mu 0 is the condensed permeability of the space. So here is what is the magnet of the magnetic field? 2 centimeters from a long straight conductor, the current 2.5. So we have I, we have R, we want to find B. So this is the equation. We have I, R converted to the meter. Mu 0 is 4 pi 10 power negative 7. It's permeability of the free space. You need to know. And that would be the B field. So you can try question number 1 and 2 for practice. Here is when you have a coil, you have so many loops, right? What is the magnetic field produced by that? Is mu 0 N I over L. N is the number of the loops you have, I is the current, and L is how long it is, and mu 0 is the permeability of this space. Now, what is the magnet of a magnetic field in the core of this solenoid? 5 centimeter long with 300 turns, means N is 300. The current I is given. 5 R is given as well. Okay. So here is L, is how long it is. You just turn that to the meter, you have N, you have I, using the equation to get the magnetic field produced by. You can try question 6 and 7. Okay. If you have 2 wires, they will apply force on each other. How do we know? This current, this wire will produce a magnetic field on another wire, right? You know, when there's a external magnetic field and you have a moving charge, it will feel a force. Also, this wire will apply a magnetic field on the other wire, and this wire with the presence of the moving charge in the presence of external magnetic field will feel a force. If you just investigate the direction of the force, if the direction of these 2 currents are the same direction, they will be attracted to each other. It means force is going to be in this direction, and this force is going to be in this direction. Okay. I want to investigate really how we find out the direction of the force that this wire apply on the other one. Okay, this is how we do. First, I know this is the wire moving charge, right? I use my hand, my thumb in a direction of the moving charge, right? I bend my finger to investigate the direction of the magnetic field around that wire. So in front of that is go up and back of that is go down, right? So when we say in front of that go up, means this wire is in front of that. So at this place, the magnetic field is up. It's B1. B1 is the magnetic field that I want to produce here. Now I'm gonna use, I know the B field, I know the direction of the I, can find the force. Your forefinger in the direction of the magnetic field, your thumb in the direction of the current, so your palm facing direction of the force. As you see, the force is in this direction. We can investigate the same thing for the other wire. I want to find the direction of the magnetic field that I2 produce on I1. Again, this is I2. The wire is in here, right, in front of us. So it will produce a magnetic field downward here. This is B2. This is a magnetic field that this I2 will provide, produce on I1. Now, I put my forefinger down. I put my thumb in the direction of the current. Now, my palm is facing in this direction. Means the force will be here. This is F. That one will fill. As you see, this is going toward each other because these two forces is like toward each other, means this want to move here, this want to move here, means they want to come together. That's why if these two current in the same direction, they will be attracted. Same way I can prove if the current are in the opposite direction, they will repel each other. So this is the equation that tell you the magnetic field that a wire will produce, right? And here is the force between the two wire. The force per unit length, F2 over L. Is mu 0 current 1 multiplied by current 2 divided by 2 pi d. D is the distance between them. So looking at this question, what's the magnitude of the force between two parallel conductors of 2 meters long, so it's L, with a current 4 ampere, 10 ampere, I1 and I2, 25 centimeter apart is the D. We know the equation, we have L, we have I1, I2, everything in turn into the unit, so we can find the force between them. You can do question 9 and 10 for practice.